So, our next unit will be primarily on similarity, but to do similarity, you have to understand ratio and proportion. So, a ratio compares two numbers by division. So, there are lots of ways you can write a ratio. The most common ratio that you're used to are fractions. Fractions are all ratios. You're comparing one number to another. The bottom number tells you how many it takes to make a whole object or to make a set, and the top number tells you how many of those objects you have. So here this could be a set of 5 things and you only have 3 of them so far, or one object that's been broken into 5 equal pieces and we have 3 of them so far. Okay? That can also be written this way as 3, you read that as 3 to 5. When there's that colon between them, or sometimes it's written in words, but not as often. Okay, so let's look at this first example, which is an example of something that you've been doing for several years now. Write a ratio for the slope of the line containing the point -6, 4 and 6, -2, and then what does the slope tell us? Well, the slope is the change in the y's, and most people usually use the second y and then the first y because they memorize the formula as y2 minus y1, but it's not really important. I'll do it that way, and in just a second I'll show you that it doesn't matter. So if I do -2 minus the other y coordinate 4 over, I have to use the same x coordinate that I used the first y coordinate for, so that's 6 minus -6. And it's smarter to write that as minus -6. Yes, I know it's eventually going to be +6, but the problem is that when people start writing +6, then about halfway through the problems, they're like, am I supposed to be adding or am I supposed to be subtracting? You're always subtracting. All right. So then this is going to be a -6 over a +12, which is -1/2. What does the slope tell us? Well, this slope tells us that this line moves down one space each time it moves to the right 2 spaces. That's what the slope literally tells you. To get from one point to another point, we could move down 1 and to the right 2. And again, that's an example of a ratio that you've used for years. You can also have ratios that compare more than 2 numbers. This you don't have as much familiarity with probably. The ratio of the side lengths of a triangle with perimeter 96 centimeters is 4 to 5 to 7. Find the length of the shortest side. Now, when they say that the ratio is 4 to 5 to 7, are they saying the sides are of length 4, 5, and 7? No. What they are saying is that whatever they were, they reduced to that. So you could start guessing here. Like, for example, if it was 8 to 10 to 7, that reduces to 4 to 5, 8 to 10 to 14, my fault. That reduces to 4 to 5 to 7. You can reduce them just like you do fractions. You just divide everything by the same number. But we could spend a long time guessing until we got one where the perimeter was 96. So here's what we're going to do. Notice each of these is 2 times the 4 and the 5 and the 7, right? They're all multiplied by the same number. Well, let's call the number that they're all multiplied by x. So 4x 5x, and 7x. And the perimeter is the sum of all the sides, so if I add these three together, it should be equal to 96. Combining the like terms, we get 16x is 96. Divide both sides by 16. We get that x is 6. So the shortest side is going to be the 4x because 4 is the smallest coefficient there. So it'll be 4 times 6 is 24 centimeters. Take 96 and divide it by 4. But that's not going to, why 4? Right, but if you divide 96 by 5, you're not going to get the length of the middle side. It doesn't work that way. It's not 1/4. It's 4/16. It's 1/4 actually, not, doesn't always work that way. Okay, yes?
I have another one. This of the ration.
Ratios?
If I do it that way and I consistently get the answer little.
What are you going to do?
So I add the 4, the 5, and the 7. And then I, like, if I'm looking for the one that's 4, so I do 4 over 4 plus 5 plus 7, which is 9.
4 plus 5 plus 7 is 16.
So that'll be 4 over 16 times 96, which is the total.
Yeah, you can do that. That's fine. Just show that that's what you've done. Yeah. All right, let's look at this next one. Here we've got the angles of a triangle are in a ratio of 2 to 5 to 8. Again, it has to be 3 because there's 3 angles in a triangle. Find the measure of the largest angle. Well, we can do the same sort of idea we did on the last one. 2x, 5x, and 8x are going to be your 3 angles. What do we know the angles in a triangle add up to? 180. So that'll be 15x is 180. Dividing, we get that x is 12. So then the largest angle is going to be 8 times 12 is 96 degrees. Any questions about that? All right, page 2 then. Something that's closely related to a ratio is a proportion. A proportion is an equation stating that 2 ratios are equal. So for example, 7 over 35 is equal to 1/5. That's a proportion. It says that those 2 ratios are equal to one another. So one of the most famous properties of proportion is called the cross products property. You probably just called it cross multiplication because that's what you do. If you have A is to B as C is to D, then if we cross multiply, so multiply diagonally across the equal sign, we get A times D is equal to C times B. You've probably used this for several years. And we're going to use that to solve some problems. But we're going to be smarter about it than you perhaps were when you learned this in maybe late elementary school or even in junior high. Because I'd like to make this easier. So I'm not going to cross multiply to start with. what I'm going to do is reduce this so that I have smaller numbers to work with. So if you got 56 over 72, what are both of those evenly divisible by? They're both divisible by 8. So 8 goes into 56 how many times? 8 times 6?
No. 7, yes.
7. And 8 goes into 72 how many times? 9 times. Hey, look at this. If 7 over x equals 7 over 9, what does x have to be? What does x have to be?
9.
X has to be 9. I don't even have to cross multiply. If you'll reduce the fractions, a lot of times you don't even have to cross multiply. They didn't tell you that when you learned cross multiplication as a way of solving things. Now, this next problem, not so easy. First of all, we cannot reduce anything here. Occasionally I have a student who goes, well, can't I divide the 4 into the 20? No, because it's not x times 4. So here, our only hope is to cross multiply. So we'll have 5 times 20 and x minus 4 times x minus 4. Five times 20 is 100. Now, on the right side, you could distribute and get a trinomial, an x squared minus 8x plus 16. That's not the easiest way to do this particular problem. Do you notice that these are both exactly the same thing? So I'm going to rewrite this as x minus 4 squared. Then I'm going to take the square root of both sides. But remember that there are actually 2 square roots. There's a positive square root and a negative square root. Usually when you think of the square root, you just think of 10, right? The square root of 100 is 10. But there's also a negative square root. Negative 10 is equal to x minus 4. And you will lose tons of points on the problem if you don't do the positive and the negative. Then add 4 to both sides to solve. We got 14 is equal to x, or negative 6 is equal to x. There are 2 solutions to this problem. Anytime you have something squared as part of an equation and you're solving it, there's the possibility of getting 2 answers. Yes, sir?
Why don't you just why don't you add the x's together, like the x minus 1, x minus 4 to get 2x minus 16?
Because you're not adding them, you're multiplying them.
Well, what do you mean?
It's x minus 4 times x minus 4. So you can't add them. You're multiplying.
Yeah, I'm not multiplying. Why can't you multiply?
Well, if you really want to, you can. You would end up with 100 is equal to x squared minus 8x plus 16. Then you would subtract 100 from both sides. This would be x squared minus 8x minus 84. And then you'd have to factor this. And if you want to do it that way, that's fine. It turns out that this is x minus 14 and x plus 6. So either x minus 14 is 0 or x plus 6 is 0. So you get x is 14 or x equals negative 6. It's actually faster to do it this other way because it's the same thing. Now, if they were different, you would have to do this. We're not going to do any like that. But if they were different, you would absolutely have to do that. Okay? All right. Next thing, some properties of proportions. Okay, if A is to B as C is to D, or A over B equals C over D, it's the same thing, then we can rewrite this a couple of ways. We could take the reciprocal of both sides. B over A equals D over C. Why is that legal? Well, because it has the same cross products. The cross products up here are A times D and B times C. Down here, the cross products are B times C and A times D. Same cross products that we had to begin with. Here, we could also go sideways. A over C equals B over D. Again, it has the same cross products, A times D and B times C that we had originally. So as long as you have the same cross products, you have an equivalent proportion. All right. So there will be a problem like this on the quiz. There will be a problem like this on the test, and some of you are going to miss it. It happens every year. It's not a hard problem, but a lot of people miss it. A lot. Somewhere around 20% of the people miss it. Maybe a little higher than that. Okay. Students are really good at cross multiplying. Students suck at uncross multiplying. And that's what we need to do on this. So given that 18C equals 24D, find the ratio of C to D. First of all, that means C over D. Sometimes people get that confused, and then the only way you could get the right answer is if you made a second mistake. Equals. We got 18C equals 24D by cross multiplying. So where does the 18 belong?
Bottom.
On bottom. People want to put it on top. The C's on top, the 18 should be on top. Nope. We're undoing cross multiplication. And the 24 goes diagonally across from the D. And it says in simplest form. So I got to reduce this. Those are both evenly divisible by 6. So your answer is 4 to 3. It's not a hard problem. But again, I guarantee it'll be on the quiz, it'll be on the test, and there'll be some of you who miss it on both, which is really, really sad. All right. Let's do a word problem. So a model of a tower is made for a movie. The model is 8 meters high and 6 meters wide. If the actual tower is supposed to be 996 meters wide, how tall is the actual tower? So to do these problems, there's lots of little tricks that you can learn. I don't do little tricks for the most part, but I will say there's a good way to do any of these problems, and it's to make a table. Looks a little like a tic-tac-toe board. Notice we have 4 different things here. We've got the model, we've got the tower, we've got how tall it is, and how wide it is, right? So which ones go together? Are the same kinds of things? So I'm going to put the model here and the tower here. You could have put them on the sides. It doesn't make any difference at all. And over here, I'm going to put how high it is and how wide it is. If you set up your table wrong, you'll immediately figure it out because you'll have something like this. Please don't write this down. you'll have something like model and tower, and you're like, well, what's supposed to go here? Well, I don't know. There's nothing about the model and the tower. All right, so for the model, how tall is it? 8 meters. For the tower, how high is it?
We don't know. 997.
Do
Actually,
we-
no, we don't know.
That's the width, so we don't know this. So I'm going to put a question mark for now. For the model, how wide is it? 6 meters. And for the actual tower, how wide is it? 996. There are lots of other ways you could have done this chart, but no matter how you do it, all you have to do is write down exactly what you have here and you have the right proportion. 8 is to 6, as we'll call it x, is to 996. It will write itself literally if you put it into a chart like this.
That's the answer?
No, but that's the setup. Again, I always reduce before I cross multiply. So that's going to be 4 over 3 equals x over 996. Then if you want to, you can further simplify it, or you can just go ahead and cross multiply. It's not horrible. If we multiply across, we're going to get 3x equals 996 times 4.
3,249. No, it's 3,900. I'm just doing 4,116.
So yeah, it's going to be 4,000 minus 16. So 3,000.
984.
Yep. 3,984. Then we just need to divide by 3. So it's 1,328 meters.
Do we have to do table?
No. And the thing is that I have students every year that are like, I don't know how to set these up. And I'm like, make a table. If you make a table, it will always be right. If you don't, sometimes you'll get it right. Sometimes you'll get it wrong. All right. Let's take the quiz.